Hi everybody, I want to give you a quick summary about my project with the name Animating Graph Algorithms in the browser. As the name suggests, I want to build an app that does exactly that. The idea of this app is that the user should be able to choose some arbitrary graph algorithm. Then the user should be able to choose a graph dataset, either fetch this from an external API or use a local file. And then the interesting part is that the browser computes the whole animation instead of making use of a complicated backend infrastructure that would pre-compute all of that stuff. So last time I gave you a quick demo. Here just some screenshots because the overall layout didn't really change. So on the left hand side you will always be able to see some code or some pseudocode or some additional information about the algorithm that you've selected, and on the right hand side you can either see the raw drawing, the raw visualization of the dataset, or you can also go to the algorithm part where you can then see how the algorithm basically traverses through this data structure and changes the overall structure. And on the bottom here you can always go forth and back in time to see all states of the algorithm's execution. And you can also see here, for example, you can search for an arbitrary data set. Okay, so building this thing made me think about basically three things. Here in this slide, only two. First of all, how does such a data set even get displayed? How do we visualize this? And one easy approach is to use a force-directed graph drawing algorithm. The idea is that all the nodes are seen as metal rings or magnets, whatever, and all the edges between the nodes are seen as springs. And then in this physics simulation or this physical system, the objective is to reduce the overall stress. And what you get when you do that is usually a really nice drawing, really nice layout of this graph. It can be 1D, 2D, or 3D, whatever. And secondly, I thought about how we design even a meaningful animation, because this should, such an animation should always add intuition and not lead to more confusion. And as you could see on the last slide, I also put some thought into how to build a usable UI that is fun to use. But then thirdly, and probably the part on which I spend most of my time with, is how do we make things fast and how do we make things even more usable. Here, first of all, I thought about what kind of framework I want to use. You can always build such an app just by using plain JavaScript, HTML, and CSS, but there are harsh limitations toward like flexibility and reusability of components. And Next.js is a really nice framework, which is also really fast. Secondly, I make use of WebAssembly. WebAssembly is a compilation target, which enables us to write lower level logic in lower level languages such as C++. And this, I use that for all the computations of the algorithms and also all the computations of the visualizations. And this makes the app very fast. Then last but not least, and that's what I've done basically the last couple of weeks, is looking into WebGPU. The idea is that for some graph algorithms we want to make use of the Laplacian matrix and do some heavy linear algebra computations with this Laplacian matrix. For example, doing matrix multiplication in the most basic case. And matrix multiplication, for example, can gain a huge speed up by doing some parallelization. And the CPU is okay for doing parallelization, but the GPU is inherently very, very much built for that. And the problem was, at least in the last couple of years, that the browser, or that modern web browsers, only had some limited access to the GPU and could only use the GPU for raw graphics. And you could also always emulate compute shaders via vertex and fragment shaders, but this was really cumbersome. And WebGPU, which is this emerging technology, which isn't even supported by all browsers yet, enables us to use compute shaders and hence to do these cool computations in parallel. And that's what I'm currently researching. Thanks for listening.